Building a new AI model is thrilling, but deploying it to live users usually vanishes that thrill into a nightmare of server alerts. When faced with the terrifying question of what hardware to run it on, developers often default to the safest, most expensive guess. They just throw the model onto a massive GPU and hope for the best. This guess is dangerous. Overprovision and your budget drains by $10,000 a month on idle servers. Underprovision and servers redline when traffic hits. Latency breaches, systems crash, and your team is paged at 3 a.m. Relying on a blind guess traps infrastructure teams in a binary choice between bleeding cache and crashing servers. It's a gamble that risks 5-figure monthly losses before the first user even signs up. Figuring out the exact right hardware shouldn't be this hard, right? You look at the size of your model and buy a GPU to match. But the physical parameter count is only the first piece of a much larger puzzle. This visualization tracks how fast different serving frameworks process the exact same model. The software you use to run your AI, like vLLM, TGI, or llama.cpp, can make one setup run up to 5 times faster than the others for certain workloads. To actually find the most efficient setup, an engineer has to manually cross-reference the size of their model against framework throughput benchmarks, and then constantly check those numbers against live AWS pricing tables. Doing this math by hand takes hours of staring at spreadsheets for every single deployment. Engineers need a way to calculate these intersecting variables in seconds. The Infra Sizer command line interface was built to resolve this calculation gap, turning these multivariable deployment questions into a single automated process. You feed the tool exactly 4 things: the model ID, request per second, maximum latency, and context length. The pipeline then activates, automatically pinging the Hugging Face API to gather specific metadata for your requested model. It extracts the precise parameter count and the underlying neural network architecture. Both of these are required to calculate exactly how much memory and compute power the model will actually consume under load. By automating this initial extraction step, the tool bypasses human error and manual spec checking. It takes what used to be a hopeful guess and turns it into a hard, data-driven query. With the model data secured, the query moves into the brain of the operation, the local GPU database. The system evaluates options on a scatter plot, cross-referencing 6 GPU tiers, from A10Gs to H100s, against AWS pricing and throughput. This data is fed into the Llama 4 AI model, which actively isolates the single, absolute best configuration. And if the external API key is ever missing or offline, the tool doesn't crash. A deterministic, rule-based algorithm automatically takes over to calculate a recommendation entirely locally. By processing these variables through a reasoning model, Infra Sizer navigates infrastructure trade-offs the way a senior DevOps engineer would. The final output is delivered directly to the developer's terminal in seconds. This table gives you a concrete, actionable plan. It details the exact GPU instance type you need, the total number of GPUs to provision, the optimal serving framework, the ideal batching configuration, and a precise estimate for your monthly cloud bill. It is a remarkably elegant solution to a deeply complex, historically frustrating human engineering problem, but the source code for this specific tool holds a fascinating detail. This highly optimized infrastructure software was not written by a human developer. It was built autonomously by an AI coding agent named Neo. We are looking at an escalating loop of automation. Human engineers are now using an AI-built tool, which relies on an AI reasoning engine, to figure out exactly how to deploy other AI models. Tools like Infra Sizer put professional-grade infrastructure planning into any developer's hands. They highlight a shift in the industry. The intelligence used to build a model is now being used to deploy it.